retry, but in case anyone else is stuck on this, or if you're stuck on this particular version, let me show you approach to the style problem. So this one's a little funky because it's missing a variable in each of the equations. We still have three variables. We still have x, y, and z, but each equation has two different combinations of those. And so what you do is you just decide to eliminate something. And it'll make sense in a second why that is. Right now, these z's are kind of looking at me like that would be a really easy move for me to make. So I'll go ahead and do x plus z equals -3, and I don't have to do anything to that because I have a plus c and a minus c, and that's why I'm picking that particular pair of equations. So this will leave me x plus y. Those z's cancel out, and that will equal -3. And so that would be what I've been calling equation 4. And now the trick is you just go back to the equation you didn't use, which in this case was 1. We put 2 and 3 together, and it will now have the same variables as the one you just made. So I can eliminate y pretty straightforward from this pair of equations. Let me do that. Plus y equals -3. And then, so that makes 2x, the y's cancel out, equals -8, and then x equals -4. From there, not difficult to, plug the x in. -4, oops, that's not very 4-like. -4 minus y equals -5, so add the 4 over and get -y equals -1. Multiply both sides by -1 to clean up the signs, and so then y equals 1. And we can do the exact same thing right there with the -4 plus z equals -3. Add the 4 over, and it looks like z should be 1 in that case. So again, the trick is just to put any two of them together, eliminate the variable they have in common, and then that will match that third equation that you hadn't used yet.